Here I have a well showing several curves, with the gamma ray indicating two thin sand units. I'll use crossplots to analyse the relationships between some of the log curves for my wells. Crossplots are created in the Crossplot tab. To create a new crossplot, click the plus icon and select New Crossplot. Resize the window, then select Well Curve as a data type for both the horizontal and vertical dataset axes. Next, select the data class from the data source list. In this example, I will plot p-velocity on the horizontal axis and density on the vertical axis. Clicking the plus icon adds a well row. I'll choose the same well as in the correlation view, and finally I choose the log curves for the well matching the selected class. Once the data has been selected, the crossplot will display. This plot has points from the entire well, but I'm only interested in the deeper section. Setting the start of the range to the marker top M and leaving the end of the range as a total depth limits the points to my target interval. Let's work through some of the other settings. First, I'd like to colour the points according to another log curve. That requires a different plot type. I'll change from a bin density plot to individual point by point. More on this in a moment. I'll give the crossplot a descriptive title to help identify it. Under View Settings, there are controls for the axis settings, polygons, ellipses for lithofluid models, and annotations. Adjusting the dot size to 3, we see that the points are clearer defined. Now I will increase the amount of grid lines displayed using the slider. I will increase the polygon line thickness for the next steps. And finally, I will add a colour bar to the display. Because we haven't chosen the colour dataset, the colour bar has no colour. Back in the Data tab, change the Colour Dataset data source to Gamma class. For well 4, I'll select this gamma curve. I'll use the mouse wheel to zoom in for a closer look. When I move the mouse over the sand bodies in the correlation tracks, the cursor jumps to those points in the crossplot. These low gamma values cluster around this area of low density points. If I use a polygon to sample an area on the crossplot, I can highlight those values in the well. To do this, open the Polygon tab and create a new hand-drawn polygon by clicking the plus icon. Click the pencil to enter editing mode and draw the area in the crossplot to investigate. Right-click to stop picking and click the pencil again to leave editing mode. Select the highlight option to show curved data in the well view that falls within the polygon. Don't forget to select the correlation view tracks and turn on the crossplot highlights. There, the polygon area corresponds nicely with those sand bodies. After including a second well in the correlation, I can see similar low gamma packages. Let's add this well to the crossplot and compare those other log properties. I'll click the plus icon in the Data tab. After selecting the correct curves and restricting the data range, the crossplot updates with the new points. I can see a second area of low gamma values with a lower p-velocity than the others. I'll create another polygon for this area of the crossplot and show the points on the well logs. The orange highlighted points mostly fall in the sands of well 5, but some also appear in the upper sand unit of well 4. There's a distinct behaviour common to the sandy units of these two wells. Additional crossplots comparing different variables would help explore this further. In the Crossplot tab of the Control panel, I have some other crossplots. These can be opened by double-clicking. This crossplot of PM versus VPVS shows where the low gamma values are falling with respect to P impedance and VPVS. Highlighting the points in the correlation view shows a similar distribution as before, with the sands of well 5 being different to those of well 4. I can enable and disable wells in the crossplot to isolate the points from each other. Another approach is to colour the data points by well, using the ID number class and selecting well ID as the colour variable. Hiding the different crossplot highlights allows clear comparisons between crossplot populations and well logs. Using crossplots, I've extended my understanding of the lithology. This is just the thing I needed to take my well correlation further. Time to explore some more wells.
If you have questions or would like to discover more, then visit our website at www.doug.com. And remember, have fun with insight.